Hello everybody. This module in this module we are going to learn about sedimentary rocks, and this video is about the formation of sedimentary rocks. So there are a couple of processes that can create sedimentary rocks, including precipitation, and I'm still not talking about rain or snow here. And the second one is the process of cementation of sediments. And what we mean by sediments, they can be, any type of loose grains, such as rock fragments or mineral particles or even fossils. And here are the three major types of sedimentary rocks that we know: siliciclastic, biochemical, and chemical. For siliciclastic, this is the type of sedimentary rocks that consists of rock fragments or even mineral particles such as quartz or even clay minerals. And the other two, this guy, they are made of mostly of ions that have been concentrated and precipitated out of water solution. So in this video, we are going to focus mainly on siliciclastic sedimentary rocks. The reason for this is because siliciclastic sedimentary rock is the most common type of sedimentary rocks on Earth. Okay, so it's very important to learn about this in more detail. So in order to create siliciclastic sedimentary rocks, we need these 5 processes right here. Okay, starting from weathering, erosions, transportation, deposition, as well as lithification. Okay, and next, later we will learn about lithification being it can actually be further divided into 2 major processes, including compaction as well as cementation. So let's learn about weathering and erosions first. Weathering is a process of breaking down the rocks and decomposing bedrocks near or at Earth's surface. Okay, and there are 2 types of weathering that we know. First is called physical weathering. The second one is called chemical weathering. So, for example, if I have an exposed rocks just like this, the atmospheric processes will promote a process called weathering. Okay, it basically will break down these rocks through physical or chemical weathering. Okay, and then after that, erosion will take place. Erosion is a process of removal. Is a removal process of those particles. Okay. So for physical weathering, this is the definition of it. It's a process of breaking down the rocks without changing the chemistry of the rocks, without changing the mineralogy of the rocks. Okay. So for example, here I have a rock here that gets buried deep inside the earth, and then for some reason there's a process of removing these layers of sedimentary rocks above it. Okay, maybe through some erosions or something like that. So the removal of these layers of these overlying sediments, it can actually release some pressure around this little box right here, and that could create, or that could actually cause rocks to develop some cracks or fractures. Okay, and in this example, we will see examples of exfoliation fractures or vertical joints or horizontal joints. Okay. By the way, when we say joints, these words simply mean fractures within rocks. Okay, or cracks within rocks. All right, this is an example of exfoliation in granite. As you can see here, exfoliation joints, they look like onion skin that has been peeled off. So it looks something like that, and that is what we call exfoliation joints. And the second one is these vertical joints. This is also an example of physical weathering. Okay, and the process or the development of these vertical fractures within basalt in this example could help this basalt to weather out more easily. and breaking it down into smaller pieces or smaller particles. Okay, and also notice that there are also some horizontal um, joins that develop within these rocks right here, or semi-horizontal joints. And this is also another example of physical weathering called frost wedging. This happens because of the freeze and thaw cycles. These cycles can actually pry open any existing cracks within rocks. So, for example, here I have a fracture within rocks, and these fractures will be filled with water. Okay, and that water will freeze during the winter time. Okay, and remember that when water freezes, its volume actually expands for about 9 to 10%. Okay, so therefore that process is called frost wedging, because it actually the freezing of water actually helps pry open the existing fractures within rocks. So therefore it helps breaking down the rocks. And don't forget about the role of organisms, such as the development of root with tree, associated with this tree growth on the surface of the earth, and also humans' role in breaking down the rocks. Okay, so those are the examples of physical weathering, and now let's talk about chemical weathering. This is the process of breaking down rocks involving changes in rock mineralogy or the chemistry of the rocks. And one of the example here that I'm going to show you is dissolution. So for example, if you have salt that is submerged within water, salt typically consists of sodium and chloride. Okay, so this molecule of sodium and chloride, these ions of sodium and chloride, can actually be removed by dissolving it into water. So this water molecule will attach themselves with these ions of sodium and chloride. Okay, so this process is the dissolution. Because we have now we have dissolved salt within the water. All right, this is just an example of evaporites or salt rocks that have been dissolved. And this is also a great example of dissolution or chemical weathering. Okay, the process of development of stalagmite or stalactite here in these caves, they actually develop due to the process of dissolving the bedrocks, and in this example would be carbonate bedrocks. And these carbonate bedrocks will react with groundwater and eventually create these beautiful structures in these caves. Okay, and whenever you have caves, they, if you don't have a lot of support here, could also eventually create some sort of like a sinkhole. Okay, so the development of sinkholes, they are commonly associated with dissolution of the bedrocks with groundwater. And the other two examples that I would like to mention here for chemical weathering include oxidation and acid rain. For oxidation, typically we have metal elements such as iron that react with oxygen, and they typically occur in open air, can also occur underwater, and it actually something that we are a bit familiar with, or the process of um, you know uh, rust production in rocks, basically. And the last one is called acid rain. This happens because we have some excess of carbon dioxide in the atmosphere, and carbon dioxide will mix with some rainwater. Now, when this happens, this is not pretty good for carbonate rocks, because carbonate rocks are known to be a type of rock that reacts very well with acid. So therefore, acid rain could help breaking down carbonate rocks. All right, the next process is called transportation. This is simply the dispersal of solid particles by either gravity, wind, water, or ice. Okay, so after the particles being removed through erosions, those particles can go through this river and being transported into sites of deposition. Okay, maybe at the beach or marine environment here in this example. But the process of bringing these particles from its original points all the way where to the second place where it will be accumulated, this process is called transportation process. And one of the major agents of sediment transportation is water. So remember about the gush of water in streams or river or ocean waves maybe. These are all agents of sediment transportation. And remember that grain size is a function of a transportation process. So for example, here is coarse grains of sediments here. Coarse grains of sediments typically indicate that we have a short transportation, okay? Whereas long transportation will create fine sediments such as sand or mud size sediments, okay? So again, the grain size is a function of transportation process. Short transportation will produce coarse sediments, whereas long transportation will produce fine sediments, like in this region right here. And the last process is called lithification, and it involves two major processes, including compaction and cementation. But the lithification itself is a process of transforming loose sediments into solid sedimentary rocks. Okay, so for example, here I have sediments, a pile of sediments being buried, maybe in a shallow water, shallow marine environment, for example. All right, so if we take a look at this cross section of this environment, or the burial of the sediments, it would look something like this. Okay, so here as we go deeper, then the pressure is increasing, and that pressure will squeeze the water out of the sediments. Okay, and eventually this is what's going to happen. So during compactions, the burial increases pressure and squeezes out water as well as air and compacts grain. So for example, here initially I have this amount of sediments being compacted. Basically it gets squeezed out. Okay, from 50 to 60% of water becoming 10 to 20% of water. And then typically, if we look further into a much smaller scale into the rocks, there are some precipitations of water from the groundwater, precipitations of minerals from the groundwater. Okay, so those minerals that are being precipitated out, those are the glue that actually hold these particles, these sediment particles together. Okay, and that process is called cementation. So a combination of compaction as well as cementation, these would create lithification, or will create a solid sedimentary rocks. So I think that is all that I would like to say in this video. And again, as usual, if you do have question, let me know. Send me an email or ask me through Canvas messaging system. I'll see you again next time. Bye bye.